Oh, okay. Just a moment. Wait. I have a technical issue.
Oh, I will take your time. I think for us to do the presentation together with demonstrations is always taking a lot of pressure to our presenter. Yeah, we'll be there quickly. But meanwhile, just quickly update on the session we have today. So in the first part, we will have Anastas to talk about the how to support the robotics using 5G testbed. This is a new piece of knowledge for most of us who come from robotic background to see what actually 5G and 6G testbed can do for us. And then second part will be tutorial session. We will show you some hands-on experience on creating network applications, and then give you some example on how to build up the semantic knowledge in the middleware. As we mentioned yesterday, we are trying to support the composition of the network applications using semantic knowledge and also optimize the provision of resources. So this will demonstrate later and how to onboard in the NetApp, etc. And then we will have a roundtable discussion at the end to really hear from you on what is your expectations. We have Anastas back. Are you ready to go ahead?
Yes.
Perfect. Go ahead.
I think my mouse was disconnected. I'm not sure what happened here, but thank you for waiting. My name is Anastas Nergitsis. I'm a part of Equadrat, and today we're going to talk about maximizing the robot performance by using edge cloud computing and 5G testbed. This is more of a personal work rather than Equadrat work. So let's begin with some of the basics, some of the issues that cloud and edge robotics have at the moment. The incorporation of advanced algorithms in robotics has led to an increasing demand for more powerful computing resources. However, the onboard computing capabilities of the robots are frequently limited, usually more expensive, and may not be able to keep up with the pace of the rapid advancements in the field. In light of this, cloud computing has emerged as a viable solution, offering on-demand access to an abundance of computing resources. Edge computing, on the other hand, provides low latency access to computing resources in close proximity to the robot, which can reduce the delay compared to cloud computing in the communication between the robot and the computational resources. The emergence of 5G networks has further enabled the availability of low latency access to edge computing resources, and that leads to improvements in the overall responsiveness of cloud robotics. The integration of cloud computing, edge computing, and 5G networks, it would be better to say the fusion of these technologies has the potential to significantly expand the capabilities of the robots, lower the production price, and enhance the performance just by offering low latency access to even more computational resources than the onboard computers do at the moment. And let's talk a bit about network slicing. 5G network slicing is a feature of the 5G networks, 5G and beyond networks, we should say, that allows for the creation of multiple virtual networks within the physical network, each with its own specific characteristics and capabilities. Edge computing enables processing data closer to the source of the data, rather than sending them to the cloud for processing. So when we combine all of these technologies, 5G slicing, edge computing, 5G slicing and edge computing, we can provide improved performance by allowing for the creation of dedicated virtual networks specifically designed and fine-tuned for each use case. These virtual networks can be optimized for low latency, high bandwidth communication, which is crucial, for example, in real-time human-robot interaction. Additionally, edge computing can be used to process sensor data, for example, used for navigation, allowing the robots to make more informed decisions and respond faster than just using the cloud. Let's talk a little bit about the contribution that the Quadrat 5G mobile testbed provides to the project of 5G era. So the testbed that we have built utilizes, we could argue, cutting-edge technology, including 5G standalone architecture, edge and cloud computing, offering a comprehensive end-to-end solution for enhanced performance and personalization. In case of HRI, the combination of these technologies allows for seamless communication and access to computing resources, improving the overall responsiveness and capabilities of the connected robots. The testbed is capable of 5G network slicing, which is an advanced method of isolating network resources. This is what we will demonstrate in a bit. And network slicing also provides enhanced security, stability, and predictable performance, since we can pre-allocate the resources. With network slicing, multiple virtual networks can be created. And each network has its own characteristics and capabilities. And overall, to explain a little bit the green bubble, the testbed in combination with the middleware of 5G era will enable the extension of those two functionalities beyond the robot. So this middleware will be able to extend the capabilities of those two beyond the robots in the cloud and the edge by using the 5G features, we could say. Before we move on, I just wanted to have this quick break. During my last talk in a robotics conference, the majority of the questions were regarding the 5G slicing. So I'll add some more comments to it. I know you're probably familiar with 5G network slicing, but this, in my opinion, this figure explains perfectly what it is and how it works. As you can see at the bottom of the picture, there are 3 gray squares. So each square represents a different network domain. We have node Bs, we have switches, routers, and servers, physical servers. This is a physical infrastructure. And by creating virtual machines and virtual links and the servers and the connections between them, we can actually create, we can pre-allocate, or we can even dynamically allocate resources to individual small virtual networks that operate on top of this physical infrastructure. A friend of mine likes to say that this looks like slicing a cake. So this is how network slicing works. This is a photo of the mobile 5G testbed that we built. This is the equipment that we will use today, that we will use for our demonstration today. Let's take a closer look actually at the equipment. We have on the right, we have We have gazebo, a laptop with gazebo. This is going to be the simulation of a robot, because the robot just arrived at our office, so we had to work with the simulation up to now. We're using the Teltonika TRB500, which is a 5G modem. Just a random 5G smartphone we have in our office. On the left, you can see the 5G base station. We use the Amarisoft Callbox Mini, marked with a red square next to the 5G base station is a tiny, tiny computer. We're gonna zoom in a bit. This is our edge node that we're using also to host the 5G related software, Open5GS core for this example. A tiny switch to connect all the devices of our edge network setup that we have here, and a tiny, tiny management router for basic functionality. Okay, here you can see all the computing and networking devices in separate pictures. On top, we have the cloud server. We're going to talk a bit about it in a moment. We have the robot simulation on the 5G modem and the edge setup on the left. All right, and we use this test bed to create a paper, to write a paper, and we presented it 2 weeks ago in HRI 2023. And this is the I'm going to present the scenario that we used to evaluate the performance of the test bed. As you can see in this diagram, we have the robot connected to the 5G modem, the 5G modem connected to the 5G base station. We have a small local network for edge computing. We have the local server, switch, the management router, and all of these are connected to the internet. It is a very, very simple setup and mobile. So with this kind of setup, the edge node has access through the internet to a public cloud provider or a remote server in our case, and that can offer quote, quote, unlimited computing resources to, to the robot. This is the view of the network slice architecture, or we could say the software side of the testbed. So very, very similar to 5G era middleware, the 5G era middleware that was presented actually yesterday. In our most recent paper, which is called Metros 5G, all network entities belong in a 5G networking slice that extends from the robot to the edge network and the cloud computing nodes. There is a bit of orchestration going on, as you can see. All robot rows to nodes were containerized and deployed using Kubernetes. And we do that to provide scalability and load balancing functions to those two nodes. As expected, a shared DDS messaging bus ensures the data exchange. And the use of the dedicated network slice actually provides security and isolation from the rest of the network, mitigating potential attacks. Okay, as you can see, it's time to take a look at the video. I'm going to post the video and comment. So this is a test bed. This is a mobile test bed. Actually, it's the smallest test bed that we have right now at our laboratory. This is
We cannot hear you anymore, Onestis.
Seems I will lose the sound from inside.
There seems to be connectivity issues with Anestis. Anestis, can you hear us? Yeah, I guess. Anestis, can you hear us?
Yes, everything is fine, but Anestis seems
Yeah.
to be having some troubles with his connection.
Yeah. I think that, yeah, he's moving his cursor, so probably he's, yeah, that's only, unless if you can hear us, just disconnect and reconnect your sound or your headset, if possible. So everyone, this is a live show, and as live shows go, we have this unpredictability.
Let me switch headsets.
Great, Anesti, you're back.
Can you hear me now?
Yeah, we can hear you now.
Fantastic. Really sorry for the break.
No worries, no worries. Anesti.
All right. So this is our cloud server. We mainly use it for AI training and machine learning training, I'm sorry, and AI tasks. This is the entire mobile testbed. On the left, we have the Amarisoft Callbox Mini, the 5G Node B. This shuttle PC is our edge node, a switch and a small management router that we use. Here you can see the dashboard with the log files of the 5G Node B, and on the right we have the Open5GS. We have 5 devices registered to our tiny 5G network. Here you can see 2 smartphones. With the left smartphone, I just wanted to show you that we have internet connectivity, and with the right smartphone, you can see by seeing this IP, we can confirm that it is actually connected to the slice, to the robot slice. Okay, can you confirm that you can hear me right now?
Yes, Anesti, loud and clear.
Perfect, thank you. Next, we have the industrial 5G modem connected through Ethernet to our laptop, which is going to be replaced by the robot next week. We actually have a turtlebot now. Okay. I left this clip in the video just to demonstrate some issues that we face at the moment, and I'll talk about them a bit later. It seems that the uplink of the Amarisoft is extremely weak and causes a lot of issues, especially with video transmission. That's why for the next video clips that we are going to see, we kept the 5G smartphones connected to the 5G network, but we connected the laptop directly to the local network just to skip the uplink and skip all the problems that we currently face with the uplink of the Amarisoft. Technically, it is still 5G connected, but not the laptop. It is just for demonstration of the application, of the demo application that we have built. Starting the application, it is just starting a Python script or a container, so nothing special here. As you can see, we have the turtlebot running. We have a remote control application. Please excuse the graphical user interface of the app. I'm not a web developer. Here you can see we can actually see the delay of the remote control. Is measured between 10 and 20 milliseconds in this demonstration. in this test, we have 7 high definition video playing and remote controlling at the same time. As you can see, the delay, there's no more delay introduced, similar to the previous clip. Okay, but let's switch to a 4K video. As you can see, the video, it is downloading at the moment, and there is already a bit of delay introduced in the video. Ooh, sorry about that. And just to demonstrate the problem that we currently face with Amarisoft, we connected again everything. As you can see, the download link is absolutely fantastic for our tests. But for uplink, yes, we have this issue that we currently try to resolve. Probably we need new hardware as we allocated double the resources to the uplink of the Amarisoft, but still the performance is not ready to be used in a production environment, let's say. All right. Now let's get back to our paper. In order to assess the effectiveness of the testbed, we conducted a use case study involving an autonomous robot that it is located in an airport, and its task is to guide the travelers to their designated departure gates. So the robot will be scanning the faces of the travelers, matching the faces of the travelers with the database entry, and responding with a personalized message, a picture of a map, before navigating to the correct gate of the terminal. This is the scenario that we wanted to study, and we performed several tests. First, we examined the end-to-end slice latency. That means that we measured the latency between the robot and the furthest container dedicated to navigation. When we say furthest, in network hops. For all different settings, okay. We used an operation to measure the latency from the robot that hosts, from the node that hosts the navigation container to the robot. Okay, for this scenario, we used 1000 samples each second for different scenarios at the same time. So all of the tables and figures we will see here are measured at the same time. As we can see in the figure, we observe that the overall latency when using only cloud for the navigation can be almost as high as 200% more latency than just running locally in the robot. So we have to compare 38 milliseconds on average to 0.016 milliseconds average. But by using a smart middleware similar to the 5G middleware, we can actually improve the performance by using edge computing. And with a little bit of smart orchestration, we can achieve a response that can be as faster as 183% than just using the cloud. Pretty close to the real time, pretty close to the onboard robot hosting. Okay, in this test, we examined the computing load yielded by the personalization functionality, which is the scanning of the faces. We instantiated face recognition scripts that we developed with Python and OpenCV. to showcase the computational load of a robot task that is used for personalization. Okay. For this test, we used the Raspberry Pi for the onboard computer, as an onboard computer. Okay, the table shows the computing load that ranges measured during the 1000 samples each second. As you can see, using Cloud Node for the personalization task uses minimal resources. The Edge node, it is very similar compared to the onboard computer. So it is apparent that the combination of edge and cloud computing is the best middle ground between latency and computing capability, and even cost, we could say. There is one thing that I still cannot understand from this table. I cannot understand why the onboard memory use, the memory usage of the onboard computer was as high as that. Probably due to the Raspberry Pi uses an SD card to load the OS from, and most of the functions of the operating system is running actually from the memory. Probably this was the reason why the memory usage was so high in our onboard test. And finally, we examined the response time of the scanning, measuring the elapsed time from the detection of a face to the response in the local display. We used a display for a Raspberry Pi. In order to perform this task in the laboratory environment, we measured and compared the timestamps of the face detection and the response from the display, we would say. So according to the scenario, the robot is searching for faces, for the faces of the travelers, matching them to their photos in the database, and returning a personalized response. As an action, the response is a map. So specifically in the table, we can see how prolonged is the execution of the personalization task when it is executed locally in the onboard computer. I'm sorry, almost 110% slower than using the Edge or the Cloud Node. That makes the networking delay insignificant for such tasks. So again, a fusion of edge computing, cloud computing, and middleware that can orchestrate the functions of the robot is the perfect middle ground for cloud and edge computing for robotics. So this is my presentation. We have plenty of time to discuss and have questions. I can go back to the slides. Feel free to initiate any discussion, not only questions. Thank you very much for listening.
Great, thank you very much. Thank you, Anastas, for this great presentation, interesting presentation. So we do have some questions from the chat. So I will start with 5 questions. So the first one comes from the telco domain. So does URLLC, for the people who are unfamiliar with the term, it means ultra reliable and low latency connectivity. It will be available in the existing 5G, 6G testbed?
Okay, so if it is
such slides be available.
Okay, so if URLLC will be available in our testbed.
Yes.
Yes, we are able to enable to offer URLLC with our testbed. The problem is that when we switch our G-Node B to URLLC mode, our smartphones cannot connect. So only the Teltonika, the 5G modem, can connect with the ultra low latency setting of our G-Node B, and we have some incompatibilities with the smartphones. Actually, every smartphone that we have in our laboratory has different compatibility with the Amarisoft Genode B. So yes, we can offer URLLC, but some devices are unfortunately incompatible with it. We cannot connect the smartphones in URLLC mode, but the industrial 5G modem definitely works.
Perfect. Which means that we will be able to also use some connectivity further for some extra applications and for some, I guess, use cases that require this kind of ultra reliability of the slice. Great. Thank you.
Definitely. This is how we measured actually the results in the figure that I showed before. Yeah, thank you.
Perfect. Thank you very much. Great. Thank you. Thank you. Interesting. So then another question from the telco domain. So do you support both the standalone mode and non-standalone mode in the testbed? And based on your experience, what is the difference, the real difference between performance in both modes, let's say?
That's a great question. We have experimented with both settings, standalone and non-standalone. Personally, I have only worked with 5G standalone mode, but with the discussions that I had with my colleagues, we have achieved better performance with 5G standalone mode. Yes, that's it.
Okay, perfect. Thank you very much. So you will, could you hear me?
Yeah, I'm right.
Yeah, great.
Sorry.
Thank you very much. Yeah, no, thanks. So another question is, does the Amarisoft core, does it simulate also traffic? So can it also simulate heavy traffic from multiple devices connected in this environment?
That's a great question. With the software that it is provided with Amarisoft, actually, we do not simulate traffic with the software that it is provided. I don't know if it is possible with the Amarisoft software, but we are able to simulate traffic with our modems. So we can, I mean, in a different setting, we can allocate the resources in a way that they are allocated in. Actually, let me think about this answer. We're using physical devices to simulate the traffic. For example, in this case, if we want to test the connectivity of the mobile phones, we can generate traffic from the Teltonica. We do not simulate traffic for our tests in the laboratory.
Great. Thank you very much. I mean, yeah, this is okay. So a lot of things to explore on the test bed. That is great. I mean, to adapt it in various environments and so on. That's great. Thank you. Thank you, Nestle. So another question is, so do we expect using the 5G test bed like the Amarisoft Mini in close to a door or close to some obstacles, let's say? Do we expect that the signal will be blocked easily through such obstacles? Will it compromise the connectivity or the actual speed of? Yeah.
That's actually a fantastic question. Thank you to whoever asked this question specifically. Regarding the Amarisoft, I mean, as a laboratory, we have to be cautious about the power that we transmit. So we cannot test beyond, we cannot test broadcasting with power higher than the limit imposed by the law. But with the test that we had in our laboratory, we have tested connectivity behind walls and other obstacles, and we found out the connectivity to be pretty stable even behind the walls. One thing that actually helps in this scenario is that we are not using millimeter wave 5G, which is easily blocked by objects. So standard 5G bands have much better reliability than millimeter wave. So to answer the question, we found out with several tests that the connectivity is pretty stable even behind obstacles and even walls.
Great, thank you very much. Honestly, very comprehensive answer. Thank you very much. Great. So 2 more questions then. I think we have some time. So another question is that compared to a standard Wi-Fi router and a 4G LTE, what would you expect? What would you say is the difference between signal coverage and upload speed for the 5G testbed? So comparing the 3 between them. So yeah.
That's also a great question. In our laboratory, we use the Microsoft Callbox Mini, which seems, personally, it seems a bit limiting. It has many limitations regarding the performance. So if we were able to use a standardized 5G, commercial 5G equipment in this setup, actually, we have way more advantages rather than just using Wi-Fi. When we use a commercial 5G modem, for example, we do not only can utilize 5G connectivity, we can utilize millimeter wave connectivity. So when there are no obstacles, you can have the absolute fastest connection and most reliable connection. When you have some objects that obstruct the signal, you can switch to another band of 5G. You can even utilize 4G. There are many technologies that you can use depending on the scenario that you are using. So just by the access technologies, you have many more options compared to just the bands of Wi-Fi. And beyond the hardware and just the performance, keep in mind that with 5G, you also have access to all the 5G features, such as the slicing and the added security and all these layers on top of 5G, on top of the access of 5G. So, yeah.
No, please, go ahead.
So to answer the question, I see that 5G, using 5G for all these scenarios is a much better and versatile option, but it depends a lot on the hardware that you actually have. At this moment.
Okay. Yeah, perfect. I mean, that's a comprehensive response. So, I mean, there is a reason why 5G and how we choose to deploy it is the best, the optimal solution at this point. Thank you very much. Thank you. So another question is that, so what can we do for the uplink of the robot and the downlink to the edge to avoid the problems that you mentioned in your video, for example? Could we adjust the ratio of the uplink and the downlink by the software? Is it, what is the configurability of the setup, let's say, to tackle these issues?
That's a good question. Actually, the Microsoft Callbox Mini that we use here can be configured, and we can use different setups. We can actually allocate some more resources in the uplink and reduce the resources of the downlink. We can have a symmetrical connection. we can reallocate all of the resources according to the task. For example, in this demo, we used symmetrical setup here. But although the Amarisoft has, it is actually extremely configurable, and you can actually dive into its, I don't know how to say that, into its base code, and even replace some of its functionality with your own. It is very good for research. I see that the performance is just not there regarding to this specific unit. So the performance that we actually need is not offered by this specific model. It's great for research, but not for production level. So to answer the question, the performance of the hardware is the major bottleneck in our case.
Okay, great. But in any case, we could potentially play, quote unquote, play with the parameters and find the optimal, let's say, for this setup. And then based on that, we can, when we go to production, we can sort of try it and reconfigure some devices in production and play. Great. Okay, perfect. And then a last question. What are your recommendations? I think this is a very common question. I think this is a very interesting question and quite a common. What is the recommendations based on your experience for selecting a smartphone as a user equipment, a UE for testing?
Oh no, we actually have the same question. Okay. Just a recommendation that somebody from Nokia, I think it was. I had a lot of conversations regarding which devices we should use in our testbed, and during the Mobile World Congress, I've met a lot of people working on these things, and the answer that most of these high-profile people, let's say, had was stick to the main brands and always get the latest possible technologies, the smartphones with the latest Qualcomm chips specifically. So that was the advice that I had from high-profile people. I'm just transferring this. This is not my opinion.
Okay, fair enough. So if I were to pressure you, let's say, a little bit, and if I had to, I would tell you I'm somewhere and I really need a UE, give me a model, but as a recommendation, not as anything else. What would be your go-to model, let's say, in that?
Go-to model. Actually, one of the most common recommendations was the latest smartphones from Samsung.
Okay.
So we, as a Quadrat, we will buy some of the newest Samsung smartphones, S23, I think, Galaxy S23 smartphones, and we'll also buy a smartphone from Nokia. I'm not sure about the Nokia, but I will definitely buy some smartphones from Samsung because they are equipped with the latest Qualcomm chips. And for UE, for another type of UE, I definitely recommend the Teltonika. It was fantastic for our tests. Really great.
Great. Honestly, thank you very much for your comprehensive responses. I think we got a lot of value from answering those questions, and people, I think, realize what is the benefit of our testbed advantages. So with that, if there are no more questions with the muting of the mic, then I think we can move on. Honestly, thank you very much for your presentation.
Thank you very much. It was a pleasure.
Thank you very much.
To you. Oh. Here we go.
Perfect. Thank you. So moving on for the next part of our session, So we have the tutorial sessions. We will have 3 tutorials today. One given by Michal Kapinus for how to create your own network applications. Another one from Bartosz Pratus concerning the importing of network applications into our middleware, and how to deal semantics with 5G era by Adrian Ledines. So I will give the floor to Michal for presenting the tutorial.
Okay, thank you. Hello, everybody. Just share my screen. I need to choose the right one. Okay, can you see it?
Yes.
Perfect, thank you. So this tutorial should cover some basics of how to create a network application. If you will browse to our reference NetApp repository, you can see in the source /Python directory that we have our reference application here is the ERA 5G object detection standalone and ERA 5G object detection distributed, which is divided into interface and worker. And you can also see that there is a ERA 5G network application template. So for the beginning or for starting with developing of network application, you can use this package and start on top of it. So for my showcase, I will use this package. I will make a copy of it, and we can together create a NetApp for example, adding 2 numbers. So I will change the name of the package like this. There is also some subdirectory with source code, so I will change the name of it as well. And now we can start with this package. First of all, it's a Python package, so we need to change some settings in the project or in the package files. So we need to change the name of the package in the project .toml file, and we can also, of course, change the description or author and other things, but I will not cover this in this short tutorial. We need to change the name of the package also in the setup.py file. There are 2 occurrences. And after that, we can update some requirements. In the moment, there are basic requirements for the network applications, which is our ERA 5G interface. Then there are some packages regarding the Flask web server and also some simple WebSocket package, which we are using for sending the results from the network application to the client. So the setup is complete like that. And now we can take a look on the source code. So we have this interface.py file, which is our entry point for the network application. You can see that at the beginning, there's nothing much for the configuration when the application is starting. It only runs the Flask server with on selected port and on all interfaces, and therefore we can create endpoints and other things. So as I said yesterday, the main endpoints for the network applications are register and connect. And in the register endpoint, once the robot calls this endpoint, the network application will create a session for the robot, and it will create a task handler for the robot and saves the task handler to some dictionary where all the clients or all the robots are stored, so we can access the task handler later. For this simple network application, you can use this register and unregister methods just like they are. You don't need to change anything. In case you want to create some more advanced network application, you may process some parameters from the client here, from the ARCS dictionary, or you can set up a GStreamer connection here, as you can see in our reference implementation, and all the other stuff. So for now, we can leave it like this, and we can move to the JSON callback HTTP method, which is REST endpoint called /JSON. It is a post endpoint, and this endpoint is meant for processing JSONs from the client. So here we can see that at the beginning, the network application check if the robot or the client who calls this endpoint is registered. And after that, it uses the session ID to select the appropriate task handler. It will unpack the JSON data from the request. And in this template, it will just send the data which were obtained from the client back to the client. So for our network application, which should add two numbers together, we need to change this behavior. So we can say that the data which should arrive should have two numbers. So we can define some format of this data. So for example, something like this. So we have a simple JSON which defines number one with some integer data and number two with some data. So to make a to add these two numbers together, once we get this request, we can create a response using the WebSockets, using the Socket.io library. And so here we have prepared some results structure. So we can say we will add two integers obtained from data. So data n1, which is the first number. And data n2, which is the second number. So like this, the network application is prepared and we can run it. Okay. Yeah. First of all, we need to be able to run it, we need to create a virtual environment and install all the requirements for this package. So I will create this environment, Python. Okay, what happened? Yeah, typo. Okay, so now we have folder env here. So we can activate this environment. Like this, you can see that now I'm inside this environment and I can use pip to install all the requirements, which are the ones I was showing before. It's basically the ERA 5G interface package. It's something related to Flask and other stuff. So now it's installed. And now I can install this particular package as well. And now we can run it. And yeah, by this information, we see that the web server on the network application runs on this port. So we can connect to it. And to be able to do it, we need some client. So we can create a simple client. And And for the client, we will again need to activate this environment. And we need to install our ERA 5G client package, which is published on Python package index. And now we can create a client. So import ERA 5G client base, or like this, but from this import NetApp client base. Just a second. And we can just create a client using this class. It only needs some callback function, which will be used for obtaining the results. So I will create this callback function. And inside this callback function, I will print the data. So now we have the client ready, and we can register. We can register to the network application. And we will need a support class from ERA 5G client package, NetApp location. And we will need to input there the address of the network application. So this one runs on my computer with the 5896 port. And I think that should be enough. And now we can use the send JSON HTTP method to send some data. And as we defined before, the data should be in this format. So N1, 1, and N2, for example, 5. After that, we should disconnect from the network application, so our data are cleared. Okay, so we may try it. Okay, we can run the client, and you can see that on the network application there is some client that sorry, someone has probably turned on the microphone. Okay, the client got registered and connected. Some data was sent to the JSON endpoint. There was some results, and after that the client disconnected. And on the client part, you can see that it was connected, and the result is 6, which is 1 plus 5. You can change it to 5 plus 5, run the client again, and the result is 10. So this is the easiest way of how to do this, but it's not always something you want, because in this case, all the computation happens directly in the endpoint callback. And if you do some heavy computation here, it will not be good. So we also have a different way of how to do this. So I will comment this out. So in this case, when I run the client did not receive anything. And we can use threading. We have some worker here prepared, which can do the data processing for us. It has some data queue. So we can define JSON callback HTTP. We can save the obtained data inside our queue. So data queue put, and it will be, we need to put there some metadata. We need to tell who wants to process the data. so the session ID of the robot. We also need to put there a WebSocket ID of the robot, so we know where to put the results. And we of course need to, yeah, this should be JSON dictionary. And we also need to put there the data itself. And we don't want to wait for the result here. So like this, the data are being pushed to the data queue. And here in the worker works like that. It runs in an infinite loop. It reads data from the data queue and processes the data and then publishes the results. So the results publishing is exactly the same as was in the interface of Pi. And to process the data, we can use this. The same way as we did it before. So we will return some JSON result with adding the data just like before, but this time it will run in separate threads, so we can do some more heavy computation here. So we will try to make it again, and yes, you can see the result is again working. Or I can change it to multiplication. Okay, I'm going to restart the server, of course. And now it multiplies data. Okay, so that was it for this tutorial, this short tutorial, and I will give the word back to Andreas.
Michal, thank you very, very much for this excellent tutorial, and we'll make sure to take also the individual video and upload it to our channel and for ease of access. So great, thank you very much for that. Any questions from the crowd? Anything that you would like to?
Could I ask a question? Just
Of course, yes, thank you.
to Michal, yesterday, I think there was a question about handling different kind of input data. You mentioned about the JSON serialization can be used in the case. So in case I'm transferring, let's say, a point cloud, so for defining the input and output, what is the general procedure? Am I expecting to have some serialization process to be enabled and to get the back data or point cloud data to be transferred?
Yes, yes, you can use some standard methods, standard libraries. I guess PyCoco works for serialization of different data structures. So the core package, our package, provides you with this basic tool of sending JSON, and of course, based on requests from other partners, we can provide some sets of predefined serialization methods. Like the point cloud is a great example because it will be probably used by a lot of people. So it's something we should really think of adding to the client. But if you have some really specific data, you need to create the serialization procedure by yourself.
Perfect. So this would be very useful. I'm sure it will be used, at least in our use case, for PPDR, we will collect some point cloud, and also for manufacturing process, they will definitely need to get some point cloud to be transferred.
Yes. I think that the point cloud, as I said, is a great example. It will be used by many people, so it does not make sense that each of you need to create your own serialization methods. So yes, so to everybody, if you have this request, just feel free to add it as an issue to our GitHub, either the reference NetApp or the client, and yeah, we can take a look in it.
One more question is that expecting to have this software to be integrated in a ROS package to be released to the ROS community. And so your tutorial will be very helpful for us to have them in some form of more publicable way, and then we put them together with the ROS package. So what you show to us is very useful way and to do the tutorial for general audience.
Okay.
Great, thank you very much. That's all question from me.
Thank you.
Great, thank you very much. Any other questions to Michal for the tutorial? Okay. In any case, at any point, feel free to contact us either through our website or, as Michal mentioned, on the GitLab, on the GitHub, sorry, on our public GitHub. So feel free to interact with us, and we are very responsive to get back to you. Yeah, so thank you very much. Okay, due to a technical issue for the presentation of Bartosz, we will be replaced. I mean, not replaced. It will be presented by Adrian. So the next two tutorials will be presented by Adrian. Yeah, there were some issues. So yeah, Adrian, please, the floor is yours. Thank you very much.
Okay, good morning, everyone. Can you hear me properly?
Yeah, we can hear you clearly.
Okay, perfect. So I will start with a presentation from Bartosz, and then I will move on to my presentation of onboarding network topology. So let's start. Okay, I will share my screen. Okay, so first let's start with this one, onboarding of road task. Okay, so in this presentation, we will be having a look into how we can onboard into the middleware our high-level robot task. So imagine we have a robot, and we want this robot to accomplish some specific high-level task, like PPDR, like some task that requires multiple actions with multiple network applications, or even just one, it doesn't matter. We would like to register this semantic task for the robot to later on request it, or for any robot to request it. So this is our main challenge: give the middleware the semantic knowledge to do the potential robot task. So in this tutorial, we will be having a look into how we can onboard into the system this task that we want to create. So our solution is, of course, providing onboarding endpoint for complex tasks with multiple actions in action sequence. We have provided some Python utilities to accommodate the deployments from Kubernetes to be included in our JSON file for onboarding. Of course, we have provided some examples of how to do this. So let's have a look into one example. In this example, we will be having a look into how we can onboard a task that will deploy action, which is in Nginx. So for creating a task to deploy Nginx, we'll be having some JSON that has the template, and then we have nginx.yaml and nginx.service.yaml. These are the normal Kubernetes deployment files. We have one for the deployment and one for the service. The service one is optional, as you may not want to expose the service outside. And then what we have is that we have created some flatten.yaml JSON string Python script. This Python script is mainly responsible for converting this YAML file into a one-line sequence. So by using this utility, in which we will specify input file and the output file, we will be converting this to this. So this is actually the input to the JSON body of our request. In this case, we have to do the procedure for both the YAML file and the service.yaml. So we'll run our Python script and we will convert our deployment to this new model, which basically puts everything with this character, so we don't have it in such a way. And then what we are going to do is we will copy paste this information about our deployments here and here. So let's go very carefully through this template. This is one of the easiest templates since we are only having one action in the action sequence. So first of all, we define some ID, we put some name. This is Nginx web service for webinar. And then inside the action sequence, we have one action. If for any reason we want to put more actions in the task, so first we do navigation, then we do image recognition, then we do grasping, where we just put comma, and we put another one, and imagine one third one, and we put another one. So now we have a task with 3 actions in action sequence. So obviously, you can see here we have some order. So in this case, like it is right now, these 3 actions will be deployed in parallel, since all of them has order 1, 1, and 1. So this means the task will deploy all of the 3 actions at the same time, and the robot will be able to consume them at the same time. Imagine that we don't want this, we want a sequence. So in that case, we will just put here, we want this action of order 2, and this is order 3, meaning that once the robot says, I am done with this one, then the middleware will deploy action 2, and after the second one is finished, we will deploy action 3. In this way, we can create a sequential or parallel network applications deployment, which is very flexible for the robot, since for any kind of complex task, most of the time we will have multiple applications running at the same time. So this is the way we will do it. So coming back to our one action sequence task, we have here we can define priority, and then we have action status, which is none. So let's say priority is high, and then we can define some requirements of our network application. So imagine the object recognition network application is very computationally heavy, so we can specify what are the minimum requirements for the machine that is used for deployment to match these computational requirements. And then the important thing in terms of the actual deployment is over here. We have a tag for reusability, meaning that if we put it to be true, this will mean that other robot that is around and wants to consume a network application that has been already used by another robot, instead of deleting this network application, then other robot can consume it, and we will not delete it and deploy another one, but rather use the one that other robot was using. And then finally, we have the Kubernetes deployment. We have some description, some name, and then, as I was saying before, we have the Kubernetes deployment and the Kubernetes service. So as you can see here, is one line. So this is why we need actually the Python utility that will translate the template to the one line format. And then all we need to do is we copy our onboarding template, let's say, and we can go to either our Figera dashboard, or we can use Insomnia or Postman. And over here, we will just paste our template, and we will be calling the endpoint for creating a task. This task has one action. Obviously, we need to be logged in, so make sure first we are logged in. We will get our token. We will paste it in the authorization, and finally we will send our task. And over here we have response 200, meaning that our task has been successfully onboarded into the, in this case, the Redis backend of the middleware, which is the database for all the knowledge. And we will be able to visualize. I don't know if I have here. Yes. So if I can put here task and I copy the ID, we should be able to see in Redis our task onboarded. Yes. So over here, there is only this information. This is actually because the other information is stored under the different entities. So this is actually can be very well visualized here. So probably the task is this bubble, and then this bubble consists of an action. This action has actually an instance, and this instance actually has some container. So this is actually the way the middleware is translating the action into a graph. The graph consists of action, of task with multiple actions. Each action has instance, and each instance has a container image. So by having this, we can now deploy our network application using middleware. And yes, that's it for onboarding of task and network application into the system. If you have any question, I will be happy to answer. And if not, we will be moving on to the following presentation, which is going to be onboarding the network topology of our system.
Great, thank you very much, Adrian. Thank you for the presentation. Yeah, as you mentioned, if anyone has any questions, please let us know, or and we will make sure to upload the tutorial also by itself.
Yes, yes. In this case, we are using this template for Nginx, but for example, for Beauty's NetApp, we have the Docker images uploaded to AWS. And in that case, it is from AWS where they are taken from, but it can be AWS or any other repository. That's only puntualization I want to make.
Thank you very much, Adrian.
So, yeah.
We can move on. I think that if there are no questions, then we can move to the next tutorial.
Okay, yes.
Great.
So finally, for our system to be fully on board, I know we've been onboarding many elements. We've been onboarding our knowledge with regards to the task. We have been onboarding our robots. And finally, there is one extra item we need to include in the system for the proper functionality. And this is the onboarding of network topology. So obviously, we have some testbed, we have some infrastructure, and we want our middleware to be able to plan according to the given network topology. So if we want our network application to be deployed in the cloud, or if we want our network application to be deployed in the edge, first the middleware needs to know, okay, what is this edge, or what is the IP address, what is the way for connecting it, what are the characteristics of this edge, or what are the computational resources of this machine, so I can accommodate network applications knowing that they will be properly running in such a place. So to do this, the solution is, of course, onboarding the network topology. And in here we have an example of how middleware is doing planning with graph. Middleware is doing graph-based planning for resource allocation. So over here we have two edges, and in this image, what we are seeing is that there is a network application that is currently being deployed in some particular edges. This is the way we actually do representation of the current situation. So whatever has been deployed, the middleware properly represented in the graph form for keeping tracking of planning. Okay. So for onboarding network topology, we have created examples, onboarding templates and documentation. Please visit our documentation in GitHub. Under onboarding, you have the necessary guides to onboard your network topology. And there are some examples for either cloud and edges to be used. So onboarding network topology includes onboarding two kinds of elements. In the 5G era middleware, we represent these two elements either as edges or clouds. Edges are local computational units, and clouds are units like AWS, Azure, and so on. So in this tutorial, we will be onboarding an edge and a cloud for later we use in the middleware for resource-based planning. So here is an example. Again, we are using Postman, and we will go very quickly through the actual template. This template is not as big as the robot one. This is actually a small one, and it includes some very basic information like the name of the edge, MAC address, IP address, and then some meta information like what is the organization that has this edge. So in this case, the edge we are onboarding, it is part of the organization, which is Open University of Bedfordshire. And then finally, there are some information about the computational resources like CPU and RAM. And for cloud, it is actually the same, which is very nice. So we will be showcasing example, if I can get out. Yes. So here I have prepared endpoint for edge onboarding and for cloud onboarding. As you can see here, the template is already ready. So I would just send a request. I will have obviously status 200. Again, if we copy this ID, we go back to, we are going to use Redis Insight, but in the very near future, in this case for the hackathon, you will be able to use our 5G dashboard to do the visualization of all these items. So you don't have to use admin tool like Redis Insight, which isn't really part of the solution exposed to the final user, let's say. So we will go to Redis Insight, we go over here, and we try to, I'm not sure if I can do it like this, edge. Yes, so here is our edge onboarded. For the cloud, this is actually the same procedure. Of course, make sure to be logged in before running the endpoint. If not, you will get unauthorized response. And yes, very easy peasy. Network topology has been onboarded. We have a cloud and an edge for the middleware to distribute the deployments, either in local environment like Edge or in AWS, in Azure, to be used. And yes, that has been it. I will be now very happy to answer any questions with regarding to onboarding. These are all the items that are actually required for the proper functionality of the middleware. Just to recap, we need to onboard a robot, we need to onboard the task that the robot wants to use, and we need to onboard a network topology. And with that, it will be fully working.
Perfect. Thank you, Julian. Thank you for giving us all the steps, the go-to guide on how to upload a fully functional robot. Okay. So, any questions regarding that? Regarding any of the presentations that Adrian has presented?
One quick question to Adrian.
Yes.
So if I want to check out the onboarding process, where is the best place I can find the relevant resources to do it myself?
I'm gonna put in the chat the link for everyone to have it. I'm not sure if these presentations will probably upload them somewhere. The PPT,
Yes.
I mean. Okay.
Yes, I will gather everything and then create a folder that everyone can access them and send them through.
Okay, I'm gonna actually very quickly share my screen. So this is our GitHub repository. I'm gonna put in the chat the link for it. The documentation is divided into the roles. So there is administrator role, there is developer role, and there is user. So under administrator, for example, you have information of how to install the middleware. So if you are the administrator role, you have the information here to deploy the middleware. But if you want to do onboarding of system under user, you have onboarding. And in here you have procedure for onboarding a new user, which is something we didn't really do, registration of a new user, login, and then you have onboarding of robots, edges, and clouds. And of course, you have examples for all of them in our documentation. So it should be fully available to everyone to replicate. In the hackathon, all of this we have been presenting, onboarding the full system. We will do it with everyone. We will actually help all of you to deploy the system in your own virtual machines or in your own environment. And you will get to deploy your own network applications and hopefully even allow the robot to consume them. Yes, and that would be our next big event, the hackathon.
Great, thank you very much, Adrian. Any other questions? Okay, great. So with this, we can move on now to the roundtable discussion, where we have a free forum for the people participating for any questions, any comments. All of our speakers are here that you've seen yesterday and today. So if you would like to have any questions regarding the presentations, the deployment, or any other issue, any other topic that has been discussed, this is the time to let us know. And of course, we'll be happy to answer any questions. On my side, just to start the discussion, because we have been discussing the hackathon and it has been mentioned throughout all the presentations in both days. Renshi, would you like to give us a few more details about the hackathon and planning ahead, let's say, or what can people expect from the hackathon?
Sure. Let me share my screen. I will see. We have a quick slides on the 5GR hackathon. The hackathon is planned for 1 month from now. It is again a Wednesday in the end of April. What we are planning to do in the hackathon, this is also subject to our audience. You let us know what you want, but the intention of the 5GR hackathon is that for you to do everything our presenter showed you during the webinar. So you will be able to prepare a 5GR deployment environment when we talk about distributed robotic applications. No matter you're using ROS 1, you're using ROS 2, then we want this to be fully distributed. So we show you how to do the deployment environment yourself. And then Michal showed us how to create your own network applications. So we will use the chance for you to do a network application yourself and just create a new network application, because we know a lot of developers within the 5GR consortium or outside of 5GR consortiums are working on advanced distributed applications for robotics. So this is your opportunity to do applications, follow the guideline of a 5G era, follow the reference of 5G era, then you will be able to have your scalable distributed services to be created. And this can be 1+1, Michal showed us, or can be transferring of some images or other component. Let us know what you want, and then we will accommodate your request. And then Adrian showed you about the semantic relationship, about the robot onboarding. So we will give you the chance to create your own dummy robot and create your own semantic relationships for the deployment. If you're having an environment which involves, let's say, some manufacturing process, some robot, or you have an environment with autonomous vehicle, by all means, you can create your own instance, but we will show you how to do a dummy robot and how to do the semantic relationship. You can scale them up for your own installation. And then after that, repeating what you got early from Adrian. So we will show you how to get the robot onboarded and how do you get your network application to be deployed into the 5G era deployment environment. So with everything prepared in the previous step, you will be able to have the application offloaded from the dummy robot into the targeted edge and cloud environment. So that is a full package. We don't want this webinar only for ourselves. This is a showcase of what you can do. That's the whole ambition of the 5G projects. Make this kind of awkward development for large-scale distributed environment on 5G testbed easier for you. So you should be able to do the same. And we will follow the agenda in the hackathon, and everyone here are highly encouraged to follow up the webinar we have now to the 5G hackathon later on. You have, all invited to join us, and Andreas is the dissemination manager of the 5G project, and he will be the face of contact for you. And also from Bedfordshire, you have Mr. Radu Propescu, and he is the leader for the hackathon. So you can also send email to him to ask him about questions about hackathon, and then we will accommodate you for the event. You can come here in person. This is definitely highly welcome, and you can be with us in our lab, run our robot to do the deployment of distributed application. You can also do it online. So we will have this one. It's a hybrid event, meaning you can join the event online and then set up your own environment and make sure everything is ready. For people come here, it's easier for you to do the environment, but for people actually doing them remotely, we will have a pre-session because we want to make sure on the day we do the hackathon, you already have a working environment. So which means that on the 25th, we will have pre-session for anyone who is remotely. So you can kick in just to make sure you get your functional environment prepared, and we will help you to do that. So that's pretty much our plan to ensure you can do the same as we showed you today on your own environment. That's pretty much our plan for the hackathon, and we are looking forward to your input. Say what actually you want to have in addition to our developer showed you today. If you want some additional features, you want them to be incorporated into the hackathon, you're actually doing some development, feel free to add in, and we will have this one to be considered to incorporate them into our development. If we could, we add them into the hackathon on the 26th. And otherwise, we will add more similar events in the future. If you have some very specific demand, we can help you. We will put them into the agenda. Eventually, if you recall what I showed you yesterday, there's a sequence of events. So you can find us next month in UK, in Bedfordshire. And then in June, you will be able to find us in the EUCNC special session for distributed robotics. And in September, you can find us in Brno. November, you can find us in Athens, and the next year in Cambridge. And eventually, our coordinator is in Valencia, and they are the big producer of mobile robot. So we are here to help you to deliver the distributed robotic systems. That's it. That's my selling for our hackathon, and really looking forward to all of you coming to us. You're muted. Address. Unmute yourself.
Yes, you're right. Thank you. Thank you very much for this great presentation, Renchi, indeed. And well, we're, as Renchi said, I mean, I couldn't put in better words. We're here for you. So we look forward to seeing you in the hackathon and up close in our events. Yeah, so, I mean, well said on that front. We will send also a survey to all of you. Of course, it's not mandatory, but we will be glad to see your needs and to gauge how to better prepare our hackathon. So based on what Renchi has said, we will release a survey. Please feel free to fill it in your spare time and give us some idea of how to better prepare to suit your needs. We are fully flexible, and we can and we really want to accommodate you. So this is our primary goal. So that's it from me on that front as well. Great. Any other questions for our speakers? This is one very good opportunity for you to resolve any questions, any issues you may have thought that might need resolving.
I guess if we have no more questions, that is end of our second day of the webinar.
Yep, indeed. A big thank you to Renchi and to all of the speakers today and yesterday for their presentations. A big thank you for the tutorials and for the great input and value added to our communities. And we will release everything online, of course. We will let you know when everything is uploaded on YouTube, on our channels. And of course, the GitHub is one of the most valuable resources that we have as a project for Q&A, to visit and check all of the material in. So we invite you. It's open to everyone. And with that, thank you very much, and see you soon in one of our other events. Have a nice day.
Thank you very much. See you next time.
Thanks very much.
See you. Bye.
Bye.
Thank you. Bye.
Thank you. Goodbye.